So we're not supposed to talk anymore, or
No, it's not
No, we can
anymore.
do.
we can.
No, we can. If you want to talk, let's have a look now. An error occurred. Okay, I'm just trying to. Oh, good. Hello and welcome to this Falling Walls Circle Table. I'm Zulfikar Abani, a senior science editor with DW Deutsche Welle. And this is Industrial AI, or the challenge of scaling AI in the physical world. Now, as you'll all know, the Falling Walls Circle Tables are part of Falling Walls 2020, of course, perhaps, but also part of the Berlin Science Week and also the Remote World Science Summit. They're a chance for global science experts from academia, from business, from politics to get together to exchange ideas for a new tomorrow. And that's really what we want to focus on today. Asking, where is AI today? Where do its advocates want to take it? What needs to happen in order for that to happen? And how do you, whether you're an expert in your own right or an interested party, indeed all of us, how do we feel about things like AI ethics and trust? Can we talk towards a policy proposal today, something to change the state of play? In our preparatory talks, I do remember someone said something about painting a positive picture rather than the common sci-fi dystopia. But I wonder, who's to say that a tech utopia is any better? Now, with over 200 sessions on offer at Falling Walls, if you've chosen to come and join us today, thank you so much. I hope you're ready to get stuck into the debate yourselves. We've got a chat function running, so make sure you do pitch in. There'll be a Q&A in the final 15 minutes of this short hour, but I will also be taking questions as they crop up and as we go along. Now, let's scoot on, because on our panel, we've got a very exciting clutch of experts. Some of them, of course, also Falling Walls veterans. Starting alphabetically, Michael Borler, who's both the Chief Digital Officer and Chief Technical Officer at Bosch, and also a member of the Board of Management there. And Michael is the lead in AI at Bosch, where they're keen on ethical uses of the technology and human control. Sami Haddadin is the director of the Munich School of Robotics and Machine Intelligence at the Technical University of Munich. He's also done a stint at the German Space Agency, the DLR, I noticed. So our conversation may indeed veer off into space if you don't stop me. Andrew Ung is the CEO and founder of Landing AI, an industrial AI company that wants to empower customers and realize AI's practical value. I'm intrigued about this AI-powered vision inspection tool you've got, Andrew, so perhaps we can talk about that as well in a moment. And also we've got Bernhard Schökopf, the director of the Max Planck Institute for Intelligent Systems. Bernhard, very interestingly, I find, is working on a common sense-based artificial intelligence. That alone is quite interesting to me, linking actions to real-world causes rather than this idea of correlation or recognized patterns. So welcome to everyone. Thank you very much for being here. Let's get to know you all a little bit. But hold on a minute. Before we do start proper, I have a small conflict of interest to declare here. I'm afraid I have to admit to owning a Bosch dishwasher. As a journalist, I have to admit these conflicts of interest here. I must admit it. I feel the need a little bit to talk about that while we've got Michael Borler here. This dishwasher of ours has served us well for the last 6 years, and planned obsolescence aside, say it lasts another 5 years, and I come back and buy a new Bosch dishwasher. What kind of AI magic can I expect, Michael? Am I going to start feeling AI more and more in the kitchen? Will it help me change my eating habits even, perhaps, so I don't have to clean the filter as frequently as I currently do? Let us into some secrets there, Michael.
So I think if you ask me as a CDO and CTO, I really have to think in the future. So 10, 15, 20 years in the future in the kitchen. And the holy grail in the kitchen and in households is really to think about service robots who are able to support you in your experience in the kitchen. So small examples of this are vacuum cleaners, which we currently have autonomous in your home. And in the future, I'm convinced we will really see service robots. And coming back to your dishwashers, which are perfect engineered devices out of our company, I think the dishwasher of the next generation will be very much aware about its usage. It will predict about its behavior and its status in the future. So it can remind you and can partly automatically buy material it needs. It can predict that certain things are not in order and, for example, deal with service engineers in your home. So
So I won't have to deal with the technicians either. I mean, so, Michael, that's great already. I mean, I just wanted to jump in there. And I do apologize, but robotics, you mentioned robotics a lot, and I've seen sort of like robotic kitchens and that. Sami Hadidin, you're a robotics expert, and you're also very interested in this idea of embodied AI. Are robots the best way for humans to interact, or let's say interface, as people like to say, with artificial intelligence?
Well, I mean, in a way, it depends obviously on how you design the robot on a physical manifestation, so the body, and how you design the algorithms that have to be kind of entangled with this body on the one side, and then on the other side, the big question is obviously a little bit like connecting to what Michael was just saying. Are these robots really designed to be of use, of assistance to humans? So I think one of the fundamental, let's say, challenges that we are all facing, given all the technological advancements, however, at the same time, also limitations we face as engineers, as computer scientists, and as kind of innovators in general, we need to design systems that are designed to be of use, which we call generally human-centered robotics, AI. And I think robots are, to some extent, the perfect manifestation of what you could call embodied AI. So artificial intelligence with a body that is acting, interacting in the world. And a very central kind of entity in this world is obviously the humans. So all of us. And we want to have robots, intelligent robots, so embodied AI systems that are not only kind of designed for autonomous purposes, so to execute certain tasks. You were mentioning my stint at DLR, so for tasks such as autonomous exploration of space, but let's say autonomous exploration of the kitchen, to quote what Michael was just saying, but they should also be of assistance to us, so we should be able to use them, to interact with them. Okay. And I think just by the nature of physics, it's causality in some sense, right? So we need to be compatible with physics and
Sami, let's not get ahead of ourselves here. You've mentioned a whole lot of stuff there. Now, I've been reminded to mention the chat function once again. I did mention it at the top. There is a chat function. Please put your comments in there. As I said, I'll be taking questions as they crop up during the conversation during this hour. We've already heard a lot of terminology here thrown in. A lot.
So now, for me, it's frozen.
Okay. It's frozen. Oh, don't, no.
Yeah, now it's good.
It's going to unfreeze now. Right. Okay, good. We've done the magic there. Excellent. Now, listen, let's get out of the kitchen. I want to, move a little bit out into the outer world, because that's what we are also talking about here now. Of course, I've spent a lot of time stalking our guests online before today, including you, Andrew. And I came across a video that you made about using AI technology in order to sort of order a car wash remotely. And this is a very human-centric use, isn't it? Something that also that Sami and Michael have already been talking about. How can industry be sure that people want these forms of AI in their daily lives? What do you think?
I think that people don't want AI in their lives. They just want problem solved and the things that AI can do for them. So when I lead my teams, at Landing AI, when I speak with business leaders, I usually say, don't tell me about your AI problems. Tell me about your business problems. And it's my job to work with you to figure out if there is an AI solution or not. And sometimes there is, and sometimes there isn't. The thing that excites me about AI is, despite all the hype and excitement about AI, what my community, the AI community, has done, which includes a lot of people, right, including all of you on this call, we've transformed the software internet industry and created tremendous value. But I think the next wave of value creation for AI will be outside the traditional software internet industry. And for us to take AI to the physical world, to the manufacturing plants, to the people's kitchens, to the car washes, that feels like it will be an even bigger wave of value creation than the software internet sector. And of course, one of the unfortunate things is there's a lot of urgency at management boards and C-suites to embrace this, because there's a urgent and disruptive technology.
Okay, we'll get into that. That's very interesting stuff there, Andrew. Thank you very much. Now, as I said, I've been stalking you all. I want to go even broader than your car wash problems, and that I want to think about this here. How far is AI going to go? Now, Bernhard, I noticed that you're against the use of AI in military contexts, and that's a stretch away from industrial AI and indeed everyday life, at least for some lucky countries around the world. Why are you against military use of AI? I mean, there'd be an argument to suggest that an AI would make cool, emotionless calculations on the battlefield. Are there limits that we have to set today to what AI should do and can do?
Well, you know, AI, just like every technology, could be used for good or it could be used for negative purposes. And I think it's our job as the practitioners in the field to make sure that the good applications are the ones that we are talking about, that we're working on, that we are getting our students enthusiastic about. And to me, that also means that we have to signal if certain applications shouldn't be done. And I think, I mean, it's hard to predict. Nobody can predict probably how the use of AI would change wars. But to me, it sounds like a dangerous proposition. I mean, I think we have gradually moved towards a world where maybe the amount or the number of wars have gone down. And I think it would be dangerous to change this balance of power and put people in a position to wage war without significant risk. And that's why I personally, and I don't want to claim that this is the right thing for everybody, but I personally wouldn't want to be involved in this kind of AI.
Okay. Bernhard, thank you very much. Thank you to all of you for your introductory remarks, in a sense. As I said, you've done quite a good job actually there of sort of avoiding a lot of the jargon in this field of technology. And it is very important that we sidestep that jargon. I mean, starting with AI itself, ML, hybrid systems, supervised or unsupervised learnings, probabilities, patterns and causal learnings, hyperscaling, all that sort of stuff. Because we're basically talking about one thing here, and that is getting AI into the mainstream. Now, there is this idea that AI is already in the mainstream, that it's totally pervasive. But I suppose what we mean here is moving data, I think as Andrew did actually already say, moving data-driven software-based applications towards more physical applications. That is, things you can feel, you can touch, you can see. For instance, the use of, as we've said, the use of AI in embodied systems such as robotics, and beyond that, their interaction in and with the physical world. Now, dare I say it, we could be going towards an ambient kind of technology that sort of disappears from view and perhaps also from our consciousness. Have a think about that for a moment if you're watching. Is that something you would want or even trust? I mean, in fact, a thought occurs to me now. I want to try something out here, if I may. I'm calling on you, our audience. Get into the chat and tell us whether you trust artificial intelligence, whether you're an expert or an interested party, as it stands today, or how you maybe have a vision of AI in the future. Do you trust artificial intelligence? Yes or no? It's a simple yes or no answer that we're after. And we'll come back to that in a moment. So do please get stuck into that. Mm-hmm. While you're doing that, and please do keep listening, of course, as well, let's get into some details here. It sort of struck me that there is some confusion, perhaps, or sort of different interpretations of the term industrial AI. So what exactly is it? There seems to be a lot of room for interpretation here. So Michael, as CTO at Bosch, can you explain industrial AI in a line, bearing in mind that it's a technology that wants to touch all humanity, including non-experts, average folk?
Yeah, I think I would make 3 points here. So first point is for me and us as a company, the application of AI, ML to physical products and machine. This is one important element of a definition of industrial AI. Second element is that this technology teaches physical products to learn from the environment and to adapt to the environment. And the last element, which is opening up the scope also of our discussion here, is in the notion of industrial AI in our understanding, that we foresee also the usage of physical models in combination with data-driven models, and we call this hybrid models as one of the key levers in order to really bring innovation in the application of artificial intelligence and machine learning. So these 3 elements for us are key.
I'm glad you kept those 3 points very short, but I want you to unpack, or perhaps Sammy, Andrew, or Bernard could unpack this idea of learning from the environment. I mean, what exactly are you talking about? How is an AI or ML going to learn from the environment? What exactly, to what end? Any of you
maybe
can pitch in.
I can jump in. So I think it's an interesting development that happened in AI. So the old days AI systems where people explicitly programmed rules. So we programmed intelligence into computers, and this worked in relatively controlled, low complexity environments. Now in the modern AI, which is mostly based on machine learning, there has been a paradigm shift. So these rules that computers follow to exhibit intelligence are no longer programmed into the computers, but they are learned from observations, learned from experience, learned from interaction with the environment, much like human intelligence is also not programmed into our brains by somebody, but it's learned from data. And this is so you could think of the modern AI as a way to handle now also complex situations. And that connects to your question about industrial AI. So if industrial AI has something to do with the real world, then it will inherit all the complexities that we have in the real world. So it's not a computer that deals with simple type of data that somebody keyed into the computer, but it means a computer is dealing with all the complexity of the real world.
Mm-hmm. So are you basically implying there that we can get around this idea of, a junk in, junk out, or biases that are programmed into a system before it's even started? Is that what you're talking about? We can actually broaden these systems so that they are as complex as humans?
Well, you will still have biases, because you can have biases even just in the training data, just in the way you collect training data. You can get biased systems, and you can also have biases that from the way you make the machine learn from the data. So unfortunately, that doesn't resolve these problems.
Okay, now we've had a bit of a chance to speak before today, and there are some ideas I want to bring in here, some other ideas, and that is sort of moving from industry itself, from manufacturing, for instance, from machines. And I'd like to start here, perhaps. How has AI changed industry as we have known it up until now? And how can that influence the transfer of this technology into the broader society? Andrew, perhaps you can have a go at that.
Yeah, so candidly, I think it's in the very early phases. To illustrate one example of what Bernard said, one thing that I find exciting is automatic vision inspection. Previously, we would write rules to metrology to say, is this device exactly 4.7 millimeters or something? And you could write a rule, and if it's not, then you flag a defect. But today, with modern AI, if you want to see if a smartphone you manufactured is scratched, well, I don't know how to write a mathematical formula to define what is a scratch or what is a dent and what is the discoloring. I don't know how to write a rule. But modern AI systems, which really I know Bernard and Sammy have been pioneers on the technical side, and Michael's entire team has been a real global thought leader in making this work in practical settings. This is allowing us to have AI systems learn from the environment, as you were saying, Zulfikar, from examples, what is an acceptable scratch or not. Now, there are challenges to actually getting these things to work. One of the challenges is that the data sets are much smaller. Unlike consumer internet, where you have 1 billion users and there's 1 billion data points to learn from, you may not have 1 billion pictures of scratched smartphones. Thank goodness, no one's made 1 billion scratched smartphones. So data sets are much smaller, and a lot of other practical problems. So I find that when we work in industrial AI, we need a new playbook to take these things to production. I see Michael nodding. Do you want to jump in? Because
maybe I add one comment, because Bernard mentioned that he talked about machine learning, which is let's say the mainstream currently in AI, in the success examples, and most of the algorithms live from supervised learning strategies, and this means you need to label the data, and this is an additional problem of complexity. And in our notion of industrial AI, where we need to minimize the amount of data which has to be gathered, the notion which I introduced earlier, the hybrid models, so bringing knowledge of the physical world together with data-driven models, will really be a key success factor.
So that's really interesting. We're talking about large amounts of data and smaller amounts of data. Sammy, can you give us an idea? Do you see like data-driven models affecting engineering, how you build machines, how you think about machines, how they should operate in the physical world?
Well, I think this nicely fits into essentially everything that has been said by Bernhard, by Andrew, and by Michael, saying that this fusion of models and data is more and more the way to go in these complex machines that enter the physical world, because we are not just in the correlation world or in the way that we analyze data and then do essentially predictions or classifications or things like that. But in fact, we are interacting now, or the machines are interacting with the physical world. And obviously, this interaction should take place in a meaningful and short manner. Therefore, this creation of knowledge from data and using this knowledge then to, again, acquire better data is kind of a process that seems to make this now faster and faster. So these machines are somewhat similar to, we know from our kids. So we're doing lots of interesting experiments at home with the 3 kids. They are still the eldest. My eldest daughter is 8 now, and we have 3 kids, so that's almost statistically relevant in terms of small data what we do there. So we always try to give them these challenging manipulation examples, and then you can really see how this very few amounts of examples and the embodiment that gets smarter and smarter and smarter over time, and actually quite rapidly, really plays together. So the smart body, or a smart mind in a smart body, I think is kind of what we are dealing here with.
Sammy, I hope you got your kids' consent for their use in your experimentation there.
Absolutely, absolutely, no problem.
And that they have copyright on what you learn there. Listen, but I wanted to pick up on something there because you used
they
the word.
signed.
You used the word. They did sign. Good, okay. You used the word meaningful there, and we've got a question here from our audience. And I'm just going to read this here. So excuse me as I look down at my second device here. If you have to focus on one specific area of application for AI, would you choose an industrial topic, or would you rather focus on healthcare, make healthcare, diagnostics, for instance, available to everyone, and perhaps anyone? But perhaps, Sammy, would you like to jump in there, seeing as you use the word meaningful, and I believe that healthcare is quite meaningful, isn't it, to everybody?
Yeah. Absolutely. I must say it's a great question, because it kind of also relates to the big thing question: what should we do use technology for, and what purpose should be put behind the developments that we are all pursuing? And in a way, I think there's also the question of what is possible. I said this in my introductory statement. I think we are all limited also by the technology that is around us, and kind of limited by the times that we live in. And in a way, in computing technology, we have seen that the pervasive use of computing in industry has kind of been the step before it actually kind of transited into pervasive use in our everyday environments, so towards the personal computer. In a way, I think it's very important to also understand that industry has traditionally been a very important step to kind of mature technology, to really make it safe. I mean, we are talking about physical systems that are supposed to be as safe as it can get in order when they physically interact with us. And at the same time, there is more and more applications for AI, especially for data-driven AI, that we already see. So it's not something that is in the future, but we can really use AI technologies driven by machine learning advanced over the last years, really to, for example, use them in imaging techniques and do classification there. And I think what is also coming more and more is this industrial AI concept of embodiment going into rehabilitation applications, so where this AI robotics interface is. And we are also personally pursuing here in Munich a very big initiative, which we call Geriatronics. It's about robot assistance for the elderly. So how can we actually use AI technology to really make our lives better? So I truly think these are the two driving factors behind AI advancements over the next years to come.
That is a very sort of human-centric. I mean, Andrew, did you want to say something there? I heard
I think AI is. Go for it, Michael. Then I'll go after you. All right, sure. Yeah, I think AI is very broad. Yeah, I've been saying for 5 years, AI is the new electricity, and I think the audience's question is a great question. And just as I wouldn't want to have to choose between using electricity for manufacturing versus using electricity for healthcare, we really the AI community is big enough. We should be stepping into every industries and solving all of the most, at least trying to work on all of the most important problems across society.
Andrew, I'd like to sort of plead for you to careful there, because if you say that AI is like electricity, then it gets very close to being a utility, which means there have to be very broad laws and controls in place. And perhaps we can get into that a little bit further down in our discussion. I want to move on just briefly, if I can.
I would like, Sofika, I would like
Michael,
to add one point
please,
directly related
point,
to the industrial AI notion, because I think also from a challenge perspective for the scientists, this is a great application field, because in industrial applications, you really have to think about causality, you have to think about safety, you have to think about robustness, and you have to think about explainability. And all four terms which I've just listed are really unsolved problems in machine learning of today. So also from a scientific point of view, I think this is a great application field for AI and machine learning.
Michael, I want to thank you very much for that point. I want to get into all of those things actually in this next section. But before I do that, I want to say we've had a good response from our ad hoc poll here from the audience. Thank you so much for joining in. This is quite exciting, actually. Now I'm looking down here at my other device here. It seems a bit of a tie here, 50% yes and 50% no to the question of do you trust AI? However, there are some caveats here. A lot of the yeses come with provisions. Not yet. Do not trust AI yet, but yes to a certain extent. So maybe that's actually a reflection of what you were just saying, that there are unsolved problems and it's an area that's still in development and perhaps will never reach a fixed destination. Perhaps we can get into that now, because I want to look at some of the sort of, again, I'll say it, biases and blind spots as a headline in a sense, but really where do the problems lie as we open up these so-called, a lot of people like to talk of black boxes when it comes to AIs. We're opening them up to society, and at least society has to buy into them a lot more than they may have done previously, whether that's like, autonomous cars making wrong decisions, or as we've said, sort of racial or gender biases that are inherent actually in all humans. So why shouldn't they be in computers? Now, Sammy, you said something quite interesting before, and that is that we may be facing a new problem here. And so I want to ask, are today's algorithms, are today's technologies in this area up to it? As we move to this area of this interaction of algorithms, the products, and the environment, compared to the classic machine learning AI, which only sort of operates in its own environment and could perhaps, just sort of get away with it. How do we solve this problem?
It's a great question, and I think it's a great challenge at the same time. I mean, Michael was essentially already giving some of the main challenges we see in industrial AI, and I think as a scientist or a science community in general, we see industrial AI as an application field, I guess, for this next generation of also machine learning algorithms, of algorithms in general, that are able to reason about the physical world, to act meaningfully. And it's a good question whether, and maybe it is about to be posed even more strongly, because we can see the limitations of let's say the first wave of AI algorithms in industrial sectors. We heard explainability, we heard safety, interpretability, and so on and so forth. So these are very fundamental challenges in the way that we design algorithms. And many of the fundamental challenges are still unsolved from a fundamental scientific standpoint, at least I would argue. And I think at the same time, we cannot just stop. So we should at the same time drive forward and really try to bring the right technology out and tackle these grand challenges. And industrial AI is in fact one of the great fields where we can apply. We can also have the service robotic sectors and others, but I really think that this is something where we should be aware that we need an intense research or fundamental research kind of over the next years to come, because some things just don't scale well, right?
They don't scale, but I'm also thinking about the way that we sort of view these technologies, and the word has been used once or twice, and you're right, I'm going to try and dig a bit deeper with this question, except I haven't heard it from Bernhard yet. Causality, the sort of thinking, I'm wondering about, this, because as lay people, we think of, pattern recognition and that sort of a thing, and not really sort of working off true cause and effect. So Bernhard, it's over to you. I mean, is that the next step in AI? Is that the answer to solve a bunch of these questions?
So I do hope that it's one of the technological next steps in AI. I mean, essentially, most of modern AI we've talked about that is based on statistical learning so far. And that's essentially, we've heard that before, about extracting correlations from data. And that's great because using these correlations, we could predict one quantity from others. But this prediction only works as long as nothing changes in the system. And if you intervene in a system, you interact with the system, you do something to the system, then all bets are off if you just use statistical learning. And it turns out that the modern systems, modern AI systems can be extremely sensitive towards even tiny interventions in the system, especially if they're malicious. So there's this phenomenon which is called adversarial vulnerability, where you add a little bit of malicious noise to an image and then suddenly a pig gets recognized in the airplane or something like that. And I think to make predictions which are robust also in this kind of settings, we have to go beyond mere correlations, and we have to go down to the level of what generates these correlations in the first place. And that's
Can you give us an example? Can you give us a sort of a real world example? How would that work?
Would be to say, yeah. So if you have there's a data set that gives you the human birth rate in European countries and the frequency of storks. And these two quantities are correlated. And this means that if I give you a training set of 20 European countries with both these numbers, you can learn a model that predicts the human birth rate from the frequency of storks. And you can use that model to make this prediction in another country in Europe. But if you make an intervention in a country, you bring more storks, then you wouldn't think that this is going to change the human birth rate. So this prediction that you've learned from the correlations wouldn't be robust with respect to interventions. So, and I think many questions in future AI have this kind of property that we want to be able to intervene in a system. And also, if we sort of think a little bit longer in the future, if we want to have not just artificial intelligence in the sense of pattern recognition, but in the sense of thinking like we think. And so Konrad Lorenz, the animal behavioral scientist, he once defined thinking as nothing but acting in imagined spaces. So you need an imagined space in your head, and you need a notion of action or intervention in that space to think through consequences of your actions. And so this is a form of thinking. And if we believe that in that, then interventions are key, and therefore we have to understand causality in future AI systems.
Maybe I can give
Yes, go ahead.
I would like to give an example from, let's say, our plant reality. So in plants, we have, in order to secure the quality of our products, we have several test stations which produce test results. And if a problem in quality occurs at the end of the testing line, we want to be sure what is actually the root cause. So what in a causal logic is initiating the problems we detect in the various stations. And in order to do this, you need more than simple correlation of all the data which comes out of the test stations. You need to understand causality behind those data. So this would be a direct practical application where really the engineers in the product line are waiting for this kind of root cause analysis coming out of machine learning algorithms.
Thank you very much.
Maybe there is one more point I would like to.
Please go ahead, Sammy. Yep.
Maybe if I could, thanks, because I really think this is an important aspect in the industrial AI sector, because we have now heard kind of this causality chain between events and trying to understand retrospectively also causal relations. At the same time, we talked about machines a lot, and in some sense, the physical world, I mean, that's our fundamental assumption or that's the reasoning behind all physics models that we have built over the last centuries, I guess, is the concept of causality. So the action and the interaction in the world, so just the shaking hands between you and me, if we would meet in person in the physical space, is dictated by the causal physical laws. So in a sense, there is also this fundamental concept that just the interaction itself is causal by definition, by its nature. And it's not procedural in the sense that it follows a lines of instructions, but just by grasping something, there's action and reaction. So the process itself is causal. And this is also something, a notion of understanding that so far has not been yet in machines. And this is really something that has to be brought, this understanding of physical causality also in the way that the system physically interacts with its direct environment, I guess, is kind of the last bit that really connects to the previously said.
Mhm.
Can I bring Andrew in here, because Andrew, you've been very patient there. Thinking about the example that you made before about, you know, using visual tools in order to in using AI, or even that car wash example. How does this sort of causality help you? Does it help you? Does it help predictability and also the predictability of quality in these services? What can you say about that?
Yeah, no, candidly, I think, as everyone has said, causality is important. It feels to me. Oh, and I want to shout out to Bernard Shokov. I remember, I think it was end of last year. Bernard actually wrote a very thoughtful paper surveying all the different sectors of machine learning and how causality could apply to them. I don't know if Bernard want to say anything about that. But candidly, what I see in a lot of practical settings is the technology of causality is not far enough along that I personally rarely apply that machinery to practical settings. And I find myself using, supervised learning, deep learning tools more often. And candidly, what we end up doing in manufacturing, we would detect the defect and take that to the humans, take that to the plant operators, and trust their expertise to then do the root cause analysis to figure out how to reduce the defect rate for, as a structure, gender, or discoloration, use their expertise and partner with them for the causal reasoning. In other sectors, say online marketing, one of the things I've done, continue to do, is help companies take existing customer data and figure out who are these people so we can build more efficient marketing engines, right? Cross-sell, upsell, direct impact on the top line. And what I see most companies do, and what I end up doing, is look at correlations and pretend that the correlation is causal, and then take actions under that assumption. And if the data then comes back to tell us we're wrong, then we keep on iterating to improve it from there. But what I see in a lot of customer 360 and so on is pretend the correlation you see is causal, act accordingly, drive your marketing campaigns, your product recommendations, drive your telco business, retail. These are some projects I'm working on. And then if you're wrong, the new data will tell you, and that continues to improve your model.
Okay, I mean that's very interesting, particularly for a cynic like myself, But I suppose in an area like this, even though it's been around for decades and decades, it is still developing, and in a sense, it's a bit like a vaccine. You can only really test it once you bring it out into a broad enough public. Before we move on to our next section here, I want to get into things like trust and politics and society. I'm going to take two more questions here from our audience. They've been very active today, and I think some of these things may have already been discussed a little bit. I'm just going to say them and give you perhaps 20 seconds each if you want to respond to these. Number one, first up, are rule-based algorithms all useless in deep neural networks? Can we use old rules as a warm start or initial values somehow? There's also a question here about how would you comment on Judea Pearl's AI criticism? For example, as we've been discussing, the lack of causality, or perhaps I'll put it lightly, the immaturity of causality, the fact that it still needs to develop. How would you introduce such concepts? Now, you've already discussed a lot of that. Would any of you like to pick up on these 2 points, for instance?
Maybe I would like to start talking about this question whether rule-based systems are completely out. And this nicely fits to what I mentioned in the beginning, where I say we have to enhance purely data-driven models by knowledge. This can be rules, this can be physical models, this can be other mechanisms. And so I see in the future a combination of all these elements leading to trustful AI and machine learning solutions.
If you'd like to speak, speak.
To answer the first question, I think when you have small data settings, you can't rely just on the data, and so rules are totally useful. And I think that hybrid systems, as Michael was alluding to, that allows a human to express some of their knowledge and then complement that with a limited data set, that will often do better than either pure rules or pure database learning when you have only a small amount of data.
Anybody else? I've got one more audience question, but you like to go? Yeah. Go ahead, Bernard. Yeah.
Oh, so you also mentioned the question about Pearl and causality. So, I mean, I share some of Judea Pearl's criticism. I think if we're trying to reduce everything to just a supervised input-output learning problem, we're probably not doing justice to the full complexity of the problem. At the same time, I think it's crystal clear also that we won't be able to solve these problems without heavy use of machine learning and modern machine learning methods. So I think the truth is going to be somewhere, or the path forward is somewhere in the middle, and we need to bring together these two fields. And a lot of people are starting to do that.
Sammy, would you like to, or shall we move on? I've got one other question, a technical question, that before we get into the sort of the ethics and the legal stuff and the politics and society. Would you like to comment, Sammy?
Sure. So just last thing, I think over the last 2 years, we have seen already the first unified algorithms that really bring models, you could call them rules if they are complex physical models, for example, together with data learning, with data-based machine learning. And there is the big concept we call manifold learning, which essentially is also bringing a kind of a constraint, we call that, into the way that we express the learning problem, which essentially means let's fuse prior knowledge and the data together to actually get a warm start, as you could call it. So there is already tremendous progress and probably more to come.
Okay, excellent stuff. Now I'm going to leave this other technical question till a bit later, till we get to the Q&A proper, because I really think we have to talk about some of the ethical aspects here. And there's a broad range of issues that we could talk about here. The robustness, that's a word that has been used, but also this idea of these, I'd like to say monolithic, but really centralized systems, because as AI gets deeper and deeper into society, gets more and more mainstream, and perhaps becomes more ambient, bigger, and disappears in a sense. How robust is this technology in all kinds of senses? I mean, I'm thinking of things like, if you look at democracy, it kind of works because each country has its own take on democracy, and so each regulates the other. But if you have these huge systems where all the power and all the technology is centralized, and technology does like monopolies, how dangerous is that? Or is there a chance of creating smaller hubs of technology in different places to break it up so we don't have huge centralized systems around the world? Perhaps Andrew. Oh, yeah. I hear Michael. Go ahead, Michael.
Yeah, first I would not, let's say, subscribe to the idea of the strong connection you did with using AI, machine learning, and centralized systems. So we will find AI, machine learning implementations centralized. We will find them in the edges of the network, and we will find them autonomously also in the devices themselves. So this is a completely different perspective, and but what I think is necessary is to talk about which kind of requirements, rules, or codices do we imply on artificial intelligence and machine learning to make sure that the usage is in a sense which is beneficial for societies.
Okay, so I heard I was a bit distracted by a question directed to me. Please go ahead, Andrew.
Sorry, no, I think AI is complicated, hard to give generalities. I do feel that the internet and AI are causing the pendulum to swing toward a concentration of power, because take I don't know, let's take agriculture, right? Well, here in the United States, I think I'm the only one speaking from the United States. It used to be fine used to be possible to live a pretty good life as a small scale chicken farmer, raise my chickens, sell them, have a good life. Today, because of internet and technology, the centralized players, say large chicken conglomerate, makes it easier for them to use IoT to gather data from all around the country, centralize that at headquarters, use AI to process the data, and then license back out insights or technology to all of the small scale farmers. And thus this is causing the pendulum to swing toward the concentration of power. On the flip side, and so I think this does raise challenges in terms of AI is already, and will create tremendous wealth, but I think we have a lot of work to do, and government needs to play a role as well as private companies and academia and citizens to make sure that all this wealth we create is fairly shared.
Well, and can I jump in there right away? Because you mentioned sort of government, that means politics, society has a role to play here, and also individual companies. Now, Michael, Bosch has its AI code. There are other sort of AI codes and guidelines around, and I wonder how we feel about that. these guidelines that basically set out how AI should be used and what sort of safety measures should be put in place. Is it good enough that individual companies do it, you know, at the risk of, let's say, other smaller companies just copying and pasting? Or does there need to be a broader, a larger attempt to deal with AI, ethics, commerce, etc., at an international level?
I think we do, let's say, both directions simultaneously. On the first hand, I think it's important to give our developers and the employees of Bosch a guidance. What do we want to achieve, and what do we want to do with AI, and what do we don't do? And this is a notion of our AI codex, which basically on the top level headline says nothing more than AI should serve humans and not the other way around. So humans should stay in control. This is good for our company, but in addition, we think it's necessary that we have kind of alliance also on governmental area, on European level, and maybe also on international level, and we are actively contributing to that. So there's been
But Michael, if I may just jump in there, because I mean, we hear this a lot, that humans have to stay in control, and I'm just wondering how. I mean, you know, part of the sort of in a sense, the dream or the magic of AI and machine learning is that these systems can make decisions for us so we don't have to. They can do things so that we don't have to. And it's sort of a very difficult balancing trick, isn't it, to say that humans have to stay in control? I mean, how should humans stay in control? What is a concrete way that humans will stay in control of AI or ML systems?
So I think the boundary conditions for the decisions have to be transparent and made absolutely clear. And in these boundaries, definitely the algorithms can decide and will decide. Otherwise, it makes no sense to apply machine learning solutions. So the critical point is setting these boundary conditions in which the machines can decide. And the other perspective of this is, as a necessary condition in order to do this, we have to understand under which operations or under which circumstances the AI and ML is creating decisions. So this is the notion of avoiding black boxes where we don't understand how the algorithms work. So they should be transparent.
How about the others? How do you feel about that? How do you make humans stay in control?
Yeah. So maybe just to also be a little bit of a, I want to say bummer, but I think we are while we are discussing all these wonderful potential behind AI, and also at the same time, I agree in many things that Andrew was just pointing out. At the same time, I also think that we should make sure that we are not over promising as a community and also as an industry more and more. So there are certain limitations that are just not possible, especially if we come to this physical world. There is certain limitations we cannot just simply surpass because we want to. We still, at least I would argue, we still have decades of research and development ahead of us before we really end in these. I mean, before we could even think about dystopian discussions. So I rather would argue that the positive side, we should really define and decide which direction we want to take. Healthcare, democratization of smart manufacturing, all these things that really have a promising future. And then I also think another aspect that has been tremendously underestimated over the last years, and I think we have in Germany not done the greatest deal with that, is the educational system. So we should really educate right from the beginning and make sure that society is kind of informed in the most positive but also critical way. In a way, I think we need to make the people much more aware and make them understand, educate them. What is it that we're actually doing? How do you benefit? But also the threat at the same time. So all these educational aspects are kind of always left aside. And I truly believe that this is one of the fundamental pillars on which we should put much more emphasis. And I guess we have with Andrew someone here in this round who has really done a great deal in this direction. And I truly think this is one of the fundamental pillars of our modern society, to advance science, to advance technology, but be critical at the same time. And this is something you don't do just one thing. It's a process that never stops in a way, right?
So two things. I mean, I appreciate your balance here, Sammy. That's some great points you made there. And of course, you're referring to Andrew's work with Coursera with these massive online courses.
There's actually one course I taught for Coursera that I think may be useful. I think Sammy makes a really good point. There's a class titled AI for Everyone on Coursera. There's a bunch of C-suites of large companies taking this. There's one country that I can't name, but the president of the country and his entire presidential cabinet has taken AI for Everyone. And I saw in the next year after that, that country actually seem to craft very thoughtful regulations around AI. I think that AI, because it affects all of society, is not just for technologists. It's important for business leaders as well and government leaders to learn the basics. So AI for Everyone was my attempt, to try to expose some of that knowledge more broadly.
Yeah,
I think that's interesting.
Please go ahead, Bernard, before I shoot my mouth off again.
I think this is an interesting point, that AI is, it will look different depending on where it is being built, and in different cultures, different countries, people will have different ideas how to use AI. And this connects to the question that you asked the audience before, do you trust AI? I think you will. And then we talked about technological solutions, how to make them more trustworthy. I think in the end, whether people trust AI will almost not so much depend on the details of the algorithm, but more on what kind of applications they see in their daily lives. So if they hear that AI is being used to train bots that influence elections or that do other malicious things, then maybe they will not trust AI. On the other hand, if they see that AI can be used to bring together the experience of thousands of doctors, medical doctors, and build decision support systems, then maybe people will get used to these things working, and they will say, actually, I'd rather have my doctor look through this thing before making a diagnosis.
Okay, well, okay.
Since you mentioned healthcare, quick story that relates to what Bernard and what Michael said. A lesson I learned about explainability and trust. I was building, my team and I, Anand Avanti, Nigam Shah, colleagues and I, we built a system at Stanford Hospital to look at a patient's electronic health record and predict if the patient is at high risk of dying, mortality, over the next 3 to 12 months, to recommend them for palliative care, for end-of-life care. So when we showed this model to the doctors, the doctor said, hey, Andrew, what is this? Why are you telling me this patient is going to die? Like, who are you to tell me that? So they need an explanation. So my team, we spent a lot of time generating an explanation. We use a technical algorithm called LIME, L-I-M-E, or our own flavor of it. So we could say, we think this patient is at high risk of mortality because these lab results, this test, and to me, the surprise was, the lesson I learned was, the doctors said, oh, okay, makes sense. And then they never cared again about any explanation, because they decided, got it, looks reasonable. I don't want your explanation. I'm just going to look at the files and form my own judgment from here on. So that was an interesting lesson.
Isn't that a problem, though, Andrew? Andrew, isn't that a problem in itself? I mean, you raise this idea of using AI in medicine, and of course, one of the big accusations that's often made is about how it's used or could be used in insurance, and how some people would get insurance or might not get insurance if they have birth things that they've inherited or what have you. And I believe that there is an assumption here that, in a sense, when we talk about AI, of course, I am the only devil's advocate here. You all are advocates in favor of AI. Is that there's this assumption that AI is good and it is going to continue. So, I want to know how we can sort of, like, in the last 2 minutes we have, and I need to take 2 more questions from the audience. What would you suggest, if you can give us a 20-second answer, what would you suggest now to take away for governments, for society? How do you basically make your case now so that we move forward in, the next 5, 10, 15, 20 years with AI, so that people aren't worried anymore, so that people agree with you, basically, that AI is the way forward?
Bias and fairness are serious problems. We've seen bad things happen when they weren't addressed. But I think what we need is clearly articulated standards for the bias of what to do, what not to do, and then processes for auditing AI systems against those standards. And this, I think, will help us align on what AI should do and what it shouldn't do, which is not obvious. That's more subtle, as well as to help us avoid unintended consequences while giving AI teams a clear standard to shoot for, to help AI systems realize the value that they can.
Yeah.
Okay, let's run around the panel. So next person, Bernard. Yeah.
My recommendation would be AI in itself is neither good nor bad. It's a tool. It's a technology tool. It's a powerful tool for information processing. But what will be done with it will depend also on what kind of people do it and where it is being done. And as a European, I think we should make sure that a lot of this modern AI development is also being done in Europe, because I believe in some of the values that people who live here in Europe. I believe in open societies of Europe, and I think the kind of AI that we develop will be different if it's also being done here.
Do you know, Bernard, can I just jump in there? There was a question from the audience that actually sort of alluded to this, the idea of cultural differences around the world. How do you educate the public as societies are different and people's expectations are different, people's wealth standards are different? Perhaps we can sort of like link that to what you were just talking about to Sammy and Michael there. The world is different, isn't it? It's diverse.
Yeah,
Yes,
I think from a
Sorry.
corporate perspective, like Bosch is a multinational company dealing with the various regions in the world. So what we did is, when we wrote our AI codex, we really took the regional differences into account and said there are certain guidelines which hold generally worldwide, and we will obey to them. So this is for a multinational company part of our codex, and definitely there will be other rules in Europe than, for example, in China. But there's a certain subset which we can agree upon, and this is part of our AI codex. And this also fits to the earlier question from you, Sofilka. I think it's really needed, especially in Europe, that we agree on a set of AI codices and act accordingly.
Sammy, you've got about 30 seconds.
So, yeah, so Sulfikar, I'm not sure I agree that you're the only devil's advocate. I think we're just advocates for the right use of science and technology for the advancement of our society, right? And we believe that artificial intelligence is one of the core technologies that will advance. And if we as Europeans, if we as modern society will take a stake in this development and advancements, and together with the right education and the right, hopefully right attitude to develop the right technologies for society, we hope that we can build a better society. And I think this is what we are the advocates for.
Okay. Listen, we're running up against the clock right now, and I've got to say there's one last question here. It would be rude of me if I didn't mention it. It's actually addressed to me. I can't really answer it because it's relating to the area of news reporting. It's a huge challenge at present to deal with fake news. Are there any learnings from industrial AI that can be implemented to deal with this challenge? I sincerely hope there are. Otherwise, I'm out of a job very soon. That's my short answer on that. Listen, we are coming up against the clock here. And I don't want to rush to the end. So let me take this opportunity right now to thank, first of all, the audience. You have been absolutely grand with your participation today in this session here on Industrial AI. Fantastic. Our speakers, our guests, Michael Baller, Sami Haddadin, Andrew Ung, and Bernard Schurkopf, also amazing. Thanks also to Georg Stellman at Bosch, who helped organize this circle table. And a big thanks to our production team in the studio, seldom seen but absolutely vital to these circle tables. Don't miss the daily highlights, I have to say, always every day at noon GMT, that's 1 p.m. Berlin time. You can find out what's coming up, what's been, and also coming up, actually, you might be able to catch the last hour of Künstliche Intelligenz, Organoide, Tiermodelle, Neue Konzepte in der Biomedizin. If you're into German, you can watch that. That's going till 2000 CET. Or, let me see here, tomorrow, a Falling Walls circle table, powering climate neutrality, the future of hydrogen. These all sound exciting. There are so many events on. Please do check them out. You can watch stuff live, but also catch up all at fallingwalls.com. That's falling-walls.com. Check out the website for the entire program. Thank you so much to our guests, to Michael, to Andrew, to Bernhard, and to Sami. Thank you very much. I'm Zulfikar Rabbani. Take care. Goodbye.
Thank you.
Thank you.